view the results. Okay. Now, when we say map reduce in Hadoop, it's not only the map and reduce which is happening, right? It's not a one function which is happening into the Hadoop architecture here, right? There are different tasks which get performed to get the output, right? So here I've listed what are the tasks that gets involved. So first, it's look into the record reader, maps the records, then combine the data, partition it, shuffle it, and sort it, and then do the reduce. That means any aggregation that you're going to provide, it's basically going to do, and then give you the output format, right? In many cases, it might so happen that you don't have to do any aggregate. I mean, you don't want any aggregates to be happen, right? So there, in that scenario, you can run only the map jobs, all right? Let's have a look into the example, which will give you a clear picture how the map reduce works. And here is the example that I'm going to take. Okay. So on the left-hand side, I have my blocks of the sales file in the SDFS, which basically has the zip code, the customer ID, and the amount. Okay. And the scenario is I want to get a sum of sales grouped by the zip code. Okay. So let's see how basically it works. Okay. So the mapper is basically going to map all the data. So in the data node 3, there are two map jobs which basically runs and extract out the data. Okay. And then it basically put it in a container or in an output bucket, you can say. Okay. Then it will look into the another data node 2, and similarly it will put it onto that container. And similarly, it will take the data from the data node 1 and put it over into the container. Now, this data is now basically going to get to the reduce phase. Okay. So the map phase, we basically did the mapping of the data which was available. Now what we're going to do is we basically going to do the reduce job, right? And why do we want to do the reduce task over here? Because we need the sum of sales, right? We want to do some aggregation on the data, right? So now we're going to reduce the data and see how it's going to work. Okay. So it basically first shuffles the data. Okay. Now you can see the zip code 53705 and the amount is there in the one, right? And similarly in the other containers. Then it basically going to sort the data, right? Now once it's done with the sorting, it will basically come into the in a particular sequence by the zip code. Okay. And then it basically gonna sum the data based on the zip code, and once it's get done, it basically return out the output. Okay. So this is how the map reduce is basically works in the Hadoop architecture. Let me move on to the next slide. Now the next step is to understand how this MapReduce program works in the cluster. So here I have an example in the flow. So as you can see, we have a MapReduce program that you have run. So I have run this job. It basically goes to the name node. Okay. Now name node basically initiate the job tracker, okay, which basically basically creates a new job ID. That's the first thing that's going to do, so that later point of time, if you have to troubleshoot anything, you can actually take that job ID and you can actually see in the logs why that particular job ID is failing. Okay, so this is just to uniquely identify the request that the name node is taking. Okay, so job tracker node is nothing but you can consider as a name node. But because we are now talking about the MapReduce framework, so we're talking about the job tracker node, but it's the same machine. Okay, so now you get the job ID. Okay, now once you get the job ID, the third thing is which is it basically gonna copy the job resources. So any customization that you're gonna do on your Hadoop cluster, for example, any particular functionality is not there. For example, if you're working in the pig, and if you find that a particular functionality is not available in the pig, and you write your own jar file, then probably that jar file is basically going to get copied onto the shared file system that is on the HDFS itself. Okay, so that when the job is going to run, they're basically going to take that resource and apply onto the data. Okay. Now, once that's done, the next step is the fourth step. It's basically going to submit the job. Okay. Now, what's going to happen is the task tracker node, right? These are my data nodes or my compute nodes where my individual task is going to run. So the job tracker basically it's going to create multiple tasks for me, all right? And each task is going to distribute it to the different compute nodes, okay? In each compute node, we have something called task tracker, okay, which basically launches and basically runs this map task or reduced task or maybe map reduced task over there. Okay, and once everything gets done, it's basically going to return the results back to the job tracker, and it's again, returns that result back to the client. Okay. Now at the 7th point, you can see it basically doing the heartbeat. So it might so happen that if any job is running or any task is running on a particular on the particular compute node, right? It might fail. Maybe maybe a software failure or maybe a hardware failure happened, right? So immediately the job tracker will get to know that the machines are down, and it will basically first try to do a ping 2 or 3 times to make sure whether it actually dies or not. And if it doesn't get any reply from that machine, then probably it will take that particular task and shift it to other data nodes where the data resides. Because we have 3 copies of data, right? So we can run that particular task in some other node. Okay. All right. I hope that will give you a clear picture of the MapReduce lifecycle. This is all what happens when you submit a MapReduce. And let me move on to the next step. Okay, and let me just quickly tell you about